let's get started talking about a lab report. How do we write a lab report? So a lab report has different sections, and we'll talk about each section. So the title of the lab report is going to tell you what it is all about. Okay, so your lab report is not titled lab report. Your lab report is titled, you know, something that has to do with your lab. So, for example, you know, for the germination lab, you could say germination lab. If it's something else, it'll be like descriptive about that lab. And you want it centered at the top of your page. So, if this is your piece of paper, the title is right here. Okay, I'll just erase the whole thing out. So, my style is just sometimes overly sensitive and sometimes unsensitive. Okay, so your title will be like this underneath, and then your different sections will be like this. And okay, so you're going to label each section. So this would be like the title of the section. That's what these are right here. And then this is the text of the section. So this is like the important part. Okay, so it'll look something like this. Okay. Your introduction, that's what that first section is called. So if we go back, this first section would be your introduction. Okay. So let me see if I can get the pointer. So this right here would be your introduction. Okay. For your introduction, you're going to include what your background research has shown you what is already known. So you're going to want to include citations. Okay, so you're going to have to do some research and look up kind of some information about what's going on. So if we're talking about a germination lab, you want to talk about maybe the average time it takes to germinate a seed, or you know, what's going on when a seed is germinating, something like that. So you want to include some information about background research. You want to include what you hope to learn, the purpose of the lab. You want to list the components of the experimental design. You want to list what your independent variable is, dependent variable, any control factors, and your constants. Okay. So for example, an independent variable is what we're changing in an experiment. Okay. That's the variable that we're changing. Okay, so let's say that we are changing the amount of water that each seed gets. Okay, the amount of water would be our independent variable. And then if we're measuring how large the plant gets or how quickly it germinates, that would be our dependent variable because it depends on the variable we change. Okay, your control factors are the same. Okay, so let's say a lot of times the control and the constants are the same. So let's say You know, the soil, the amount of soil would be the same in plants. Maybe the location. The amount of sun. So anything that you kept the same, and you want to keep as much as possible the same. The temperature. So if you want to see how the seed reacts to the amount of water that you give it, then you'd want to keep the temperature the same. You don't want to put one in the refrigerator and one, you know, in a sunny spot, because then, you know, you don't know if the change in temperature is what affected the dependent variable or if the amount of water affected the dependent variable. So you want to keep everything as much as possible the same, except for that one thing that you're changing. That way you can be sure that that is what's causing the dependent variable to change. Okay, and then you want to identify your hypothesis. Now, there's two ways to write a hypothesis. If you've taken statistics, you may have seen something like this. Okay, this would be called a null and alternative hypothesis. Okay, so the null is there is no difference. And the negative is there is a difference. Because these are so vague, you'd have to run some sort of statistics if you want to run a chi-square test or something like that. You have to run statistics in order to use a hypothesis like this, okay? Because you need those statistics to tell you, you know, if it's statistically significant or not. Okay, so for this one, you need statistics. So we don't use this that often, especially in biology, or because we don't require you to know about statistics. Okay, so I'm going to write require statistics here. Okay, the other thing that you can do, and that's really common, it gets used a lot, is an if-then hypothesis. So you've probably seen this. So if we do this, this pencil is going crazy. If we do this, comma, then this will happen. Okay, so if we were talking about, for example, we talked about a plant, and the change amount of water, so we could say, let's try one up here. If we change the amount of water available to the seed, then the growth rate will be affected. And you could also say something like, if I reduce the amount of water available to a seed, then the growth rate will be smaller, or something like that. Or if I increase the amount of water available to a seed, then the growth rate will be larger. You could also do something like that. This one's just pretty vague. So that's kind of what you put in your introduction. Okay. So now let's talk about the materials. In this section, it's pretty simple. You just list the materials in the lab. There's a couple things that you don't need to list. If it's pretty common, like, if you need to use a pencil to take your data, you do not need to list that. So I'm going to make a list of some common things that people put in their material section. It's really not necessary. Because you want to kind of expect your reader to be someone intelligent. So, if they're taking data, they should know to use a pencil. Okay. So pen or pencil. That's not needed to conduct the experiment. Okay. Unless your experiment does involve pens or pencils, then you would need it. Like, let's say you're making people see how fast they can write their multiplication tables with different types of music. Then they would need a pen or a pencil. Okay. Mention that the person needs their data table. Okay, that's kind of a given. It's expected the person will have their data table or paper, something like that. You don't need to say like paper for taking notes or something like that. If we're doing then yeah, we might need a piece of paper because you would need paper with multiplication tables on it or whatever. So those are some things that you don't really need, but are kind of important that you'll need, but we expect the person, whoever is doing the lab, to know that they need. Now, like, so let's say we're doing this germination lab, we would want to list seeds, and we would want to list, water and something to measure the water, because you'd want to make sure that, you're giving whatever kind of amount each day. You might want to, whatever you're going to put the seeds in, if you're using soil, that kind of stuff. Okay, now let's talk about the procedures. A procedure is it's going to be detailed, right? But you don't want to make it too detailed. So you don't just want to copy the procedure from the lab handout, okay? If you do that, you're not going to get full points, okay? So you want to kind of basically summarize what the lab handout says, and without copying word for word. You want to describe how you're going to control the variables, okay? So if you say, I'm going to give, if these are the different amounts of water I'm going to give to my seeds each day, you need to say, how much water you're going to give to each seed. You want to describe the methods for collecting data. Did we measure the growth of the seed once a day, once a week? You want to, anything that you did that was different from the lab instructions. And again, do not copy that procedure word for word or you'll lose some points. Okay. Next one. Okay, the data. So you want to construct data tables and charts to present your data collected. And you need to have a title for all your data tables and charts. So, and your title should make sense. Okay, so for example, let's say we're collecting data about, the growth of a plant. We could say, or seed growth. We could say seed or plant growth, whatever one you want. And then you could have like, seed 1, day 1, seed 2. No, these should all be day 1, sorry. And onward, and this would if you made this in a data table, it would, it would look something like this. And then you'd include your data table in your lab. Obviously, yours would be neater than mine, hopefully made on the computer. Okay. If you make a graph, you're going to want, let's say this is our data. You're going to want a label here, a label here. You're going to, you want to make it on the computer so it's nice and tidy. I've got some other videos that show you how to make graphs on the computer. If you need a best fit line, we want our best fit line to be as close as possible to all the data points. If you make it on the computer, it'll do it for you. If you don't, you'll need a ruler, and you need a title. So that's, the general idea of how you would do a graph. I think we'll get more into that in a little bit. Let's see. What's going on? Okay, so here's an example of a data table. You can see it's got a title here at the bottom. It's made on the computer, so it's neat and tidy, easy to read. If your reader can't read your data table, it's pretty much useless. Okay. In your analysis section, you're going to construct your graphs that are needed to show your results. Your graphs are going to have a title, your XY axis labeled, a best fit line, appropriate numbers on the X and Y axis. If you want to include diagrams or photos that show, like, the growth of your seed over time, like, let's say, for example, your seed is like this, and then it's like that. When you want your audience to see this growth, then you could, include these pictures, and then you would, label what's going on here, so they know. You don't just want to, like, throw a bunch of pictures in there. You want your pictures to serve a purpose. Okay, so you just don't want to include every picture you ever took in there just to be like, hey, look, see, I took a picture. You want to include pictures that add something to your report. You don't want to just put, random pictures in there. These are some examples of graphs. You can see in each of these, let's talk about what's good and bad about each of them. I'm going to use pink color because none of these have pink. Okay, so let's talk about what's good and bad about each of these graphs. This graph is a bar graph. Ooh, that's not the color I wanted. Are you kidding me? Okay. This has bar graphs because, as you can see down here, these are not numbers. Okay, these, and so if you've got numbers, you're going to want a graph with dots. But if you have something discrete, or then you'll want to put a bar graph. So, for example, the way I like to remember it is you can't have, like, New Jersey and a half, right? New Jersey and a half is not halfway between Texas and New Jersey, right? New Jersey's New Jersey and Texas is Texas. There's not, like, you're not, like, halfway to Texas. Like, there's this distance or between New Jersey and Texas isn't, like, halfway. It doesn't make sense to have New Jersey and a half, right? And so if it's something like that, then you'd want to put a bar graph. You can see they've got numbers here, and they actually have numbers on both sides, which you can totally do if you need to. As you can see right here, the distance between each of these sets of numbers is 10,000, including the bottom. Okay, so they're going by 10,000. So 0, 10,000, 20,000, 30,000, and onward. Okay, you don't want to do like 0, 5, and then 10,000, 20,000, 30,000. It doesn't make sense. Okay, on this side, they're going by 200. So the amount in between each one of these numbers is 200. Okay, each side is labeled. Okay, including the x-axis, so that's really important. You've got a title, which you need, and it's descriptive. It tells us what's going on in this graph. You know, all we see is this title. We don't know anything else, but we know that this is about car parts sold in different states. Okay, so we didn't have to read the paper or anything like that. We know exactly what this graph is about because it has a descriptive title. This one, same thing. Okay, some things that I don't really love about this one. You see here, this really should be 0 here, and then it should go 1,000, 2,000, 3,000, and this should be 0, 1, 10, 20, whatever we're doing. Okay, I don't really like how they did that. It has a descriptive title though, so that's good. I'm just going to put yay, so I don't have to write descriptive title again. And you can see here they tried to make a best fit line. So because they had a number on the x-axis, okay, they put dots for each of their data points, and then they drew a best fit line. Now, do you notice right here, this best fit line is not starting at 0, and that's okay. Your best fit line doesn't have to start at 0. The most important thing about your best fit line is that it is as close as possible to all data points. Okay, if you need to know more about best fit lines, I've got a whole video about graphing and best fit lines. But the big thing is it needs to be straight. You don't want to like have drawn it by hand. And then it needs to be as close as possible to all data points. Okay, same thing over here. Let's see what we've got over here. In this one, they're going 1, 2, 3, 4, 5. That's fine. 5, 10, 15, 20. That's good. They have an age. They have a height. They do not have a title. This one needs a title. See, we have no idea what this is about, like height and age, but like what, of certain people, of everyone in the world? Are they about, you know, a certain animal, or are they people? Like what's going on here? We don't know. Okay. In this one, they've made a connect the dot line and a best fit line, and that's okay. Their best fit line is as close as possible to all data points. It's not, you know, starting at 0. Sometimes I'll see students do something like this. You know, obviously that's not very close to a lot of the data points. That kind of a line doesn't really make sense with this data. So this is kind of some examples of things to look for when you're doing graphs. The next thing is your conclusion. You want to state a valid conclusion, and you want to explain why you think the results turned out the way that they did. Okay, explain why. You want to explain anything that's unexpected. You know, did the one with the least amount of sun grow the most? Why do you think that may have happened? Any sources of error? Here's a hint. You'll almost always have a source of error. Human error is abundant. Okay. And you want to evaluate the data and see if it supports your hypothesis. You do not want to say, my data proved my hypothesis, because nothing that we're going to do is going to prove anything. Okay. You need multiple experiments to be able to prove, and still that's really rare. Most of the time we just say our data supports our hypothesis or our data does not support our hypothesis, and it doesn't really matter. Okay.
If it doesn't support your hypothesis, you could say maybe why, or if it does, you can also say why. So some students I've noticed, they'll do their whole experiment and then they'll write their hypothesis last because they don't want to be wrong. Well, that's not, that's not really how science works, right? You want to write your hypothesis first. For example, when I was in college, I did an experiment and I asked my boss, I said, so what do we want to happen? And he said, we're not allowed to want something to happen. The science happens, and that's the way it happens. I said, right. But if we were allowed to want something to happen, what would we want? And he said, again, we're not allowed to want something to happen. We just set up the experiment as best we can, and we collect the data, and we interpret the data. We aren't supposed to or allowed to have an opinion on the matter. And he wouldn't say anything more than that because that's science. Here's an example, the rerun method for how to write a conclusion. You want to recall or restate the purpose or the problem of your experiment. You want to explain it. Why did you do the lab? What are you trying to find out? Briefly discuss your procedure. I put them in front of the same window, gave them different amounts of water. This is what happened. You want to state your results and whether your hypothesis was supported. You want to discuss any uncertainties, and then you want to talk about 2 new things that you learned, okay? And you want to write in complete sentences, okay? And one of the things they suggest is do not write in first or second person. So instead of saying my hypothesis was wrong, you would say the hypothesis was not supported by the data. Okay, so that's kind of what you put in your conclusion. And then the last thing is your sources. So if you remember in that introduction, when you looked up some background research to see, typical germination times or the amount of water that plants usually require, those places that you got that information, you would want to make a note of that and put those in your sources. And then your conclusion or discussion, anything that you had there, you would want to do, you would want to put any sources you use for that in your sources section too. So a lot of times what I'll do is I'll go ahead and I'll kind of like make my report. I'll kind of put my title with my name, and then I'll put my different sections, right? Before I do my experiment, I'll write the introduction. Okay, because then I'm getting that background research. And then when it comes time to actually write my report, after I've done my experiment, I've got one section done. Okay, now while my experiment is ongoing, okay, I'll go ahead after I've set it up. I'll write my materials section because I have already set it up. I know what I've used. Okay. And then again, you're not sitting down to write this huge whole paper when you finish your experiment. You're doing a little bit at a time, so it doesn't seem so daunting. You can do the same thing with your procedure. Okay, and then after your experiment, you'd add the data section, the analysis, and conclusion. And again, before any sources that you put in the introduction, you'd have that sources section. Let's see, it's down here. I know it's not really technically on my paper I drew, but you'd always be adding to the sources section. Okay. So anyway, that's how you'll write your report. So it's going to look kind of like an essay, except instead of an essay where all the sections kind of run together, you have like your introduction, and then you've got your 3 body paragraphs and your conclusion, and you don't really label it introduction, body paragraph, conclusion. In a science paper, you will. You'll label introduction, and then you'll write your introduction, and then you'll label materials and write your materials. You'll label procedure and write your procedure. Analysis and write, whatever you've got in your analysis. And each section is going to be paragraph form, except for your sources, which, will be like MLA or APA or whatever you want to use, honestly. Personally, I don't care. In college, they'll be pretty particular about what you want. But anyway, so that's kind of how your lab report will look. Hopefully this was helpful.